Now in conic sections, there are many questions where they'll ask you to find equation of a common tangent. So they may give you two circles, maybe a circle and parabola, parabola and ellipse, circle and hyperbola, and then we need to find equation of common tangents. Before we'll start how to find common tangent between the two given equations, we'll first recall and revise how to write equation of tangents for circle, parabola, ellipse and hyperbola in terms of its slope. So if we have this circle, which is x square plus y square equals a square, then equation of its tangent is given by y equals mx plus minus a under root 1 plus m square. If we have a parabola, then we have already studied all the four forms. So here I'll just consider this first form, which is y square equals 4ax, and the equation of tangent for this is y equals mx plus a by m, and for the parabola x square equals 4ay, equation of tangent is y equals mx minus am square. Then we have equation of ellipse, which is x square upon a square plus y square upon b square equals 1, and for that equation of tangent is y equals mx plus minus under root a square m square plus b square. And for hyperbola, which is x square upon a square minus y square upon b square equals 1, we can write this equation as y equals mx plus minus under root of a square m square minus b square. So in order to solve these common tangents problems, we must know equation of tangent for circle, parabola, ellipse and hyperbola. So let us take up an example. Now suppose the question is, find the equation of common tangent touching the circle x minus 3 square plus y square equals 9 and parabola y square equals 4x above x-axis. Now this circle whose center is at 3, 0 and radius is 3 units. So we'll draw this circle in parabola. Now we need to find equation of common tangent which lies above x-axis. We need to find equation of common tangent which lies above x-axis. So we need to find equation of this tangent. Now for this circle, we can write equation of tangent as y equals m, and in place of x we'll write x minus 3 plus minus r. What is radius? Radius is 3 and under root of 1 plus m square. And for this parabola, equation of tangent is y equals mx plus a by m. In this case is 1, so it will be simply 1 by m. So we can write this as minus 3m plus minus 3 under root of 1 plus m square, and this should be equals to 1 by m. So we have just compared the constant terms because it's a common tangent. So we need a line which is tangent to both the curves. That means these two equations, they have to be coincident lines. So from here we can write 3m square plus 1 upon m, and this is 3 1 plus m square. So if we'll square, we can write it as 9m to the power 4 plus 1 plus 6m square, and this is 9m square into 1 plus m square. So 9m to the power 4 it will cancel, so we'll get 1 plus 6m square equals 9m square. So value of m should be plus or minus 1 by root 3. Now we need to find equation of this tangent. So we'll actually have two tangents which are common to this circle and parabola, but we need this tangent, and for this tangent this line, it makes an acute angle with x-axis. So that means slope of this tangent should be positive. So from here we'll choose the value of m as plus 1 by root 3. Now once we have this value of m, we'll put it in the equation of this tangent. So we can write this equation as y equals 1 by root 3x plus root 3, or we can simplify this as root 3y, and this is x plus 3, and that's your option number C. Now here the question is, we need to find equation of common tangent to the curves y square equals 8x and this rectangular hyperbola which is xy equals minus 1. Now we know that for this parabola we can write equation of tangent. So for this parabola, equation of tangent is y equals mx plus a by m. A in this case is 2, so it will be simply y equals mx plus 2 by m. Now this line, it should also be tangent to this hyperbola, but the problem is we do not have equation of tangent for rectangular hyperbola. So what we can do is we can use quadratic method. So we'll just put the value of y in this equation. So we'll use elimination. So we'll write x mx plus 2 by m, and this is minus 1. So we'll write mx square plus 2x by m, and then plus 1 equals 0, or we can write it as m square x square plus 2x plus m equals to 0. Now this line, it touches this hyperbola, so that means there should be only one point of intersection, so that means D should be 0. So we are using quadratic method, right? So here we can write 4 minus 4, m cube should be 0, so here the value of m is 1. So the slope of common tangent to this parabola and hyperbola is 1. So now we'll just put the value of m in the equation, and we'll get this equation as y equals x plus 2, and that's your option number D. Now here the question is, the common tangents to the circle x square plus y square equals 2 and parabola y square equals 8x touch the circle at the points P and Q and the parabola at the points R and S. We need to find area of quadrilateral PQRS. So first we'll draw this figure. So we have this circle, center at origin and radius root 2, and then we have this parabola y square equals 8x. Now we need to draw common tangents to this circle and parabola. So it says the common tangents, they touch the circle at points P and Q, and they touch the parabola at points R and S. We need to find area of this quadrilateral PQRS. Now what we can do is we can write equation of tangent to this circle. So for this circle, equation of tangent will be y equals mx plus minus r, which in this case is root 2 into under root 1 plus m square. And for this parabola, equation of tangent is y equals mx plus a. What's a? A is 2. So it will be 2 by m. So it's a common tangent. So that means these two equations, they represent the same line. So we'll compare the constant term. We'll write plus minus root 2 into under root of 1 plus m square, and it should be equals to 2 upon m. So we'll square, we can write it as m to the power 4 plus m square minus 2 equals to 0. So we'll get m square plus 2 into m square minus 1 equals to 0. So value of m here should be plus or minus 1. So equation of tangent will be y equals x plus 2 and y equals minus x minus 2. So we'll consider this tangent, which is y equals x plus 2. Now for this parabola, we can find this point of contact. So we know that in parabola, point of contact, it is given by a upon m square and 2a by m. So in this case, the value of r should be, so here a is 2, so it will be 2 and then 2 comma 4. And in the same way, for this point S, we'll put m as minus 1. Then if we'll put m as minus 1, we'll get this value as 2 comma minus 4. Now we need to find the coordinates of points P and Q. So for that, what we'll do is, we'll find foot of perpendicular from origin, which is the center of this circle, to this tangent. So we can write foot of perpendicular as x minus 0 upon 1, y minus 0 upon minus 1, and then minus, we'll put the value of x, y as 0, so 0 plus 2 upon a square plus b square, which is 1 plus 1, so it'll be 1. So we'll get x equals minus y, and this is equal to minus 1. So value of x is minus 1 and value of y is simply plus 1. So this point P is minus 1 comma 1, and from symmetry we know that this point Q should be minus 1 comma minus 1. Now we need to find area of this quadrilateral PQRS. So basically it's a trapezium. So what is the length of this side PQ? So length of PQ is 2 units. What is the length of RS? Length of RS is 8 units. And what is this distance? So this is suppose H. So H in this case is, so it starts from minus 1 and 2. So this is 3. So what is the area of this trapezium? So area of this trapezium will be half sum of parallel sides, which is 2 plus 8 into 3. So it should be 15 square units. So that's your option number D. Now the question is, find the equation of common tangents to the parabola y equals x square and y equals minus x minus 2 whole square. Now we can write this first equation as x square equals y. So that's your third form. And in this case, value of a is 1 by 4. So for the third form, equation of tangent is y equals mx minus a m square. Now we'll write equation of tangent for this fourth form, which is x minus 2 square equals minus y. Now for this again, value of a is 1 by 4. So for this fourth form, equation of tangent will be y equals m, and in place of x we'll write x minus 2, and then previously it was minus, now it will be plus, so it will be plus 1 by 4 into m square. Now these two equations, they represent the same line, so we'll compare the constant terms. So I'll get minus 1 by 4 m square, and it should be equal to minus 2m and plus 1 by 4 m square. So we can write it as m square by 2 minus 2m equals to 0. So that is either the value of m is 0 or the value of m is 4. So we'll put m as 0, we'll get one equation as y equals to 0, and that's your option number B. And if we'll take m as 4, we can write this equation as y equals 4x minus 4, and which is y equals 4 x minus 1, and that's your option number A. So answer to this question is option A and B. Question is, an equation of common tangent to parabola and ellipse is y equals 2x plus 2 root 3, and statement 2 is, if the line y equals mx plus 4 root 3 upon m is a common tangent to parabola and ellipse, then m satisfies m to the power 4 plus 2m square equals 24. So we have this parabola which is y square equals 16 root 3x, and then we have this ellipse which is x square upon 2 plus y square upon 4, and this is 1. Now for this parabola, we write equation of tangent. So equation of tangent for this parabola is y equals mx plus, now what is the value of a? So 4a is 16 root 3, so a is 4 root 3. So y equals mx plus 4 root 3 by m, which is given in statement 2. And then for this ellipse, it will be y equals mx plus minus under root of a square, which is 2, m square plus b square. Now it will be a common tangent. Then these two lines, they'll be same. So we'll compare the constant terms. So we'll write 4 root 3 by m, and it should be equal to plus minus 2m square plus 4. So we'll square it, we'll get 16 into 3, and then here will be m square. I'll take this 2 common, and then m square plus 2, so it will be 8. So we can write this as m to the power 4 plus 2m square minus 24 equals to 0. We'll try and simplify this. So we'll write it as m square plus 6, and then m square minus 4 equals to 0. So value of m is plus or minus 2. So that means statement 2 is correct. So we get the same equation, which is m to the power 4 plus 2m square equals 24. And from here we'll get the value of m as plus or minus 2. Now we'll put the value of m here. We can write equation of tangent as y equals plus minus 2x, and this is plus minus 2 root 3. So one of the tangent is y equals 2x plus 2 root 3. So that means statement 1 is also correct. So statement 2, it is correct. Statement 1 is also correct, and statement 2 explains statement 1. So answer to this question is option number B. Point of intersection of tangents drawn at 2 points on a parabola. So suppose we have 2 points A and B. Now for A, parametric coordinate is at1 square twice at1, and for B, its parametric coordinate is at2 square twice at2, and we need to find this result, which is point of intersection of tangents drawn at A and B. So we know that at A parameter is t1. So at A, equation of tangent will be t1y equals x plus at1 square, and at B it is t2y equals x plus a t2 square. Now first we'll find y, so we'll eliminate x. So I'll subtract the second equation from first. I'll write t1 minus t2y, and this is a t1 square minus t2 square. So from here we'll write this y as a t1 plus t2. So for the point of intersection, its y coordinate is a t1 plus t2. Now we'll find its x coordinate. So we'll just put the value of y here. So we'll put the value of y here. We'll get a t1 square plus a t1 t2, and this is x plus a t1 square. So this a t1 square will cancel. So x coordinate will be a t1 t2. So suppose if we'll draw two tangents at points A and B, and they intersect at this point P, then the result is this point of intersection is given by a t1 t2 and then a t1 plus t2. It's a very important result which is used in locus problems. So there'll be many questions where we need to find locus of this point of intersection. So what we'll do is we'll actually take these points as t1 and t2, and then we'll take this point of intersection as a t1 t2 and a t1 plus t2, where a t1 t2 is alpha and a t1 plus t2 is beta, and then we'll try and find relationship between alpha and beta by eliminating some given condition. So we'll be using it for locus problems and for various other problems. Let us take a question, and which is two tangents to parabola y square equals 8x meets the tangent at its vertex in the points P and Q. If PQ is 4 units, prove that locus of the point of intersection of two tangents is y square equals 8x plus 2. So first we'll draw this figure. So we have this parabola, which is y square equals 8x, and then we have 2 points where tangents are drawn. Now it says two tangents to parabola meet the tangent at its vertex in the points P and Q. So this point it is P and this point it is Q. If PQ is 4 units, so this is 4 units, we need to prove that the locus of point of intersection of two tangents is y square equals 8x plus 2. So we need to find locus of point of intersection, which is say this point R, and since it's a locus problem, the first step is we'll identify this point and we'll say this point is say alpha comma beta. Now suppose these contact points are A and B, with A is given by this parameter T1 and B is given by this parameter T2. So what is the equation of tangent at A? So equation of tangent at A will be T1y equals x plus A T1 square, and equation of tangent at B will be T2y equals x plus A T2 square. We need to find these points P and Q. Now this point P, it lies on y-axis. Now for y-axis, I'll put x as 0. So then I'll get y as A T1, and for B, it'll be y equals A T2. So that means this point P will be 0 comma A T1 and this point Q is 0 comma A T2. Now it is given that distance between P and Q is 4. So that means A, and this mod of T1 minus T2, this value, it should be 4. Now we need to find locus of the points of intersection. So we'll say these locus is alpha and beta. So we know that alpha is A T1 T2 and beta is A T1 plus T2, because that is the result that we have point of intersection of tangents drawn at 2 points on a parabola. Now we need to find T1 minus T2. So from here we write T1 plus T2 as beta upon A and T1 into T2 as alpha upon A. So mod of T1 minus T2, it will be under root of T1 plus T2 whole square and minus 4 T1 T2. So we can write it as under root of beta square upon A square minus 4 alpha upon A. So this value, it should be under root of beta square minus 4A alpha upon A. Now it is given that A T1 minus T2 is 4. So we'll just put the value of T1 minus T2 in this equation. So then we'll get under root of beta square minus 4A alpha, and this is 4. Now we'll square it, we'll get beta square equals 4A alpha and then plus 16. Now here the value of A is 2. So I'll put A as 2. So we'll get this as beta square equals 8 and then alpha plus 2. Now eventually we'll replace beta with y and alpha with x. So we'll get this equation as y square equals 8 x plus 2. Now the question is, if two tangents to the parabola y square equals 4x from a point P make angles theta1 and theta2 with the axis of parabola, then find the locus of P in each of the following cases. And the first case is when theta1 plus theta2 is alpha, which is a constant. Now suppose we have a parabola and then we have tangents drawn at 2 points. Their point of intersection is suppose P, and we need to find locus of P. So what we'll do is we'll take this P as alpha comma beta, and suppose this point is A and this point is B. So A is A T1 square twice a t1 and b is a t2 square twice a t2. Now we know that point of intersection of tangents is given by alpha should be a t1 t2 and beta should be a t1 plus t2. Now it says these two tangents make angles theta 1 and theta 2 with the axis of parabola. So if tangent is drawn at A, we know that slope of tangent is given by 1 upon t1. So that means tan theta 1, it is 1 upon t1 and tan theta 2 is 1 upon t2. Now in the question it says condition is theta 1 plus theta 2 is constant and is given as alpha. So we'll take tan both sides. We'll write tan theta 1 plus tan theta 2 upon 1 minus tan theta 1 tan theta 2, and this is equals to tan alpha. Now tan theta 1 it is 1 upon t1 and tan theta 2 is 1 upon t2. So we'll write 1 upon t1 plus 1 upon t2, and this is 1 minus 1 upon t1 t2, and this is equals to tan alpha. So we can write it as t1 plus t2 is equal to tan alpha and then t1 t2 minus 1. Now what's t1 plus t2? It is beta upon a. So we can write it as beta upon a tan alpha. And what's t1 t2? It is alpha upon a. So it is alpha upon a minus 1. So we'll get this equation as beta equals tan alpha into alpha minus a. Now eventually we'll replace beta with y and alpha with x. Actually I should have taken some other point because here the angle given is alpha, but fine. So answer to this question is y equals tan alpha x minus a. Now one very common problem that is generally asked in parabolas is, suppose we have 3 points on parabola. Suppose we have A, B, and suppose we have another point which is C. Suppose that's your point C and it is given by A t3 square and then twice A t3. Now we draw tangent at C also. So now we have two triangles. One, this triangle ABC, and this other triangle which is triangle formed by point of intersection of tangents. So the question which is generally asked is the ratio of areas of triangle formed by the points and the area formed by points of intersection. So for this we need two results. First result is we need to find area of this triangle ABC. So here we have A, which is AT1 square twice AT1, B, which is AT2 square twice AT2, and C, which is AT3 square twice AT3, and then we'll find area of this triangle ABC. So area of this triangle ABC, it is 1 by 2 and then AT1 square twice AT1 and 1, AT2 square twice AT2 and 1, AT3 square twice AT3 and 1. Now from this first column we'll take A common, and from the second column we'll take 2A common, and then we'll use R1 as R1 minus R2 and R2 as R2 minus R3. So we'll write this area of triangle ABC as, and we'll need to take their modulus value, because this value, it has to be, area should be positive. So 2 and 2 will cancel. So we'll get it as A square, and then here we'll get T1 square minus T2 square, T1 minus T2 0, T2 square minus T3 square, T2 minus T3 and 0, and this is T3 square, T3 and 1. Now from this first row we can take T1 minus T2 common, and from this second row we'll take T2 minus T3 common. So we can write this area as A square and then T1 minus T2 and T2 minus T3. And then we'll have T1 plus T2, 1, 0. T2 plus T3, 1, 0. T3 square, T3 and 1. Now we'll expand it about this third column. So we'll expand, then T2 will cancel, we'll get T1 minus T3. So we can write this result as, so area of this triangle ABC, it will be A square, and then it is T1 minus T2, T2 minus T3, and then T1 minus T3 with a mod sign. So that is the area of this triangle ABC. Now we'll find the area of triangle formed by point of intersection of tangents. Suppose this is P, this is Q, and this is R. Now P is A T1 T2, A T1 plus T2. Now what about Q? Q is point of intersection at C and at B. So it will be A T2 T3 and A T2 plus T3. And the same way we can write it for R, and R is point of intersection of C and A. So it will be A T3 T1, A T3 plus T1. So now we'll need to find area of this triangle PQR. So area of this triangle PQR will be 1 by 2, and then it is A T1 T2, A T1 plus T2, and 1 A T2 T3, A T2 plus T3, and then 1 A T3 T1, A T3 plus T1, and then 1, and then its modulus value. So from this first column we'll take A common, and from the second column also we'll take A common, and again we'll do R1 as R1 minus R2 and R2 as R2 minus R3. So we can write this area of triangle PQR as 1 by 2 A square, and then here we'll have, so here we'll take T2 common, so it will be T1 minus T3, and here also it will be T1 minus T3, 0. Here we'll take T3 common, it will be T2 minus T1, T2 minus T1 and 0, and then it will be T3 T1, T3 plus T1, and then 1. So here we can take T1 minus T3 common, and here we'll take T2 minus T1 common, and then we'll expand about this third column. So we'll get this result as area of triangle PQR, and this is 1 by 2 into A square, and here we have T1 minus T3, T2 minus T1, and if we'll expand about this third column, we'll get T2 minus T3 and its modulus value. So now we have area of this triangle ABC, and we also have area of this triangle PQR. Now we need to find ratio of areas of triangle ABC upon ratio of areas of triangle PQR. So if we'll take this result, it is A square, and then T1 minus T2, T2 minus T3, T3 minus T1, and here it is A square by 2, T1 minus T3, T2 minus T1, and T2 minus T3. So A square, T1 minus T3, T2 minus T1, and T2 minus T3 will cancel. So we'll get this result as simply 2. So it's a very standard result, which is area of the triangle formed by 3 points on parabola is 2 times the area of triangle formed by points of intersection of tangents at these 3 given points. Now here the question is, consider the parabola y square equals 8x. Let delta 1 be the area of triangle formed by the endpoints of its latest rectum and the point 1 by 2, 2. Now we'll put x as 1 by 2, we'll get y as 2. So that means this point P, it lies on this parabola. So we have a point P, and then we have endpoints of latest rectum, and we have this triangle. Suppose this triangle is PQR, and P is 1 by 2, 2. And let delta 2 be the area of triangle formed by drawing tangents at P and at the end points of latest rectangle. So we are drawing tangents at P, Q, and we are drawing tangents at R. So this is delta 2. We need to find ratio of delta 1 upon delta 2. So this is standard result. We have proved in one of our videos that ratio of area of triangle formed by the points to area of triangle formed by points of intersection of tangents is simply 2. So answer to this question is simply 2. Prove that the orthocenter of triangle formed by any three tangents to parabola is on its directrix. So now we know that equation of tangent to this first form, which is y square equals 4ax, and let P, Q and R be 3 points on this parabola, which is a t1 square twice a t1, Q is a t2 square twice a t2, and then R, which is a t3 square twice a t3. Now let us say point of intersection of tangents are A, B and C. So we know that A is a t1 t2, and then a t1 plus t2, B is a t2 t3, and this is a t2 plus t3, and C is a t3 t1, and then a t3 plus t1. So now we have this triangle ABC formed by tangents. Now we need to find orthocenter of this triangle. Now we know that orthocenter lies on point of intersection of altitudes. Suppose this is D and this is E. Now we'll find equation of AD. Now this line will pass through this point A, so we can write this equation as y minus a t1 plus t2 equals, now this line will be perpendicular to BC, so it will be minus and then x2 minus x1. So x2 minus x1 will be a t3, and it is t2 minus t1, and here it will be a, and then here will be t2 minus t1, and then x minus a t1 t2. So it will cancel, a will also cancel, so we can write this as y, and we can write this as plus t3x, and it will be a t1 t2 t3, and then plus a t1 plus t2. Now in the same way we can write it for say BE. So it will be y plus say t2x, and be a t1 t2 t3, and then plus a, now it will be t1 plus t3. Now we need to prove that its orthocenter lie on its directrix. So that means its x coordinate should be minus a. So we'll find its x coordinates. We'll subtract second equation from first. So we can write t3 minus t2x, and here this will cancel, and here we'll get a, and here it will be t2 minus t3. So that means value of x is minus a. So x coordinate for orthocenter of this triangle, it is constant and its value is minus a. So that means orthocenter of this triangle formed by three tangents to a parabola will lie on its directrix. Prove that the circumcircle of a triangle formed by three tangents to a parabola passes through the focus of the parabola. So what we'll do is, we'll say, suppose the equation of parabola is y square equals 4ax, and then let p, q, r be 3 points on parabola. Suppose p is a t1 square twice a t1, q is a t2 square twice a t2, and then r is a t3 square twice a t3. Now suppose tangent at these points, they intersect at a, b and c. So we have already done this in previous article, that point of intersection of two tangents will be a t1 t2, and then a t1 plus t2. In the same way we can write b, which is a t2 t3, and a t2 plus t3, and then c will be a t3 t1, and a T3 plus T1. Now we need to find equation of circumcircle of triangle formed by these 3 points. So let the equation of circumcircle be x square plus y square plus 2gx plus 2fy and then plus c equals to 0. Now this point A, it will lie on this circle, so we can write this equation as a square t1 square t2 square plus a square t1 plus t2 square plus 2g and then a t1 t2 plus 2f and will be a t1 plus t2 plus c equals to 0. And in the same way, we'll put this value of b. We can write this as a square t2 square t3 square plus a square t2 plus t3 square plus 2g a t2 t3 plus 2fa t2 plus t3 and then plus c equals to 0. Now what we'll do is we'll subtract the second equation from this first equation. So we'll subtract the second from first. Now in the first one we'll take a square t square common and then we'll get t1 square minus t3 square. Now for the second one we'll write a square and it'll be a plus b and a minus b. So it'll be t1 plus 2t2 plus t3 and then it will be t1 minus t3. And the same way here we can take 2ga t2 common and we'll write it as t1 minus t3 and plus 2fa and here it will be again t1 minus t3 equals 0. Now here we'll take a t1 minus t3 common. So we'll take a t1 minus t3 common, then we can write this result as a t2 square t1 plus t3 plus a t1 plus 2t2 plus t3 plus 2gt2 plus 2f equals to 0. Now we'll take this third point also and then from second and third we'll get this equation which is a t3 square t1 plus t2 and then a t1 plus 2t3 plus t2 plus 2gt3 and plus 2f equals to 0 and that's my second equation. So now we have two linear equations in g and f. Now we'll solve these two equations, then we can get the value of g and f. Now again we'll subtract the second equation from first, then we can write a and here it will be t2 square t1 plus t2 square t3 minus t3 square t1 minus t3 square t2 and then plus, now here a t1 will cancel, t3 will cancel once and t2 will cancel once, so we'll get t2 minus t3 and then plus 2g t2 minus t3 equals to 0. Now what we'll do is here we'll take these two common and these two common. So we can write this as a and this is t2 square minus t3 square into t1 and plus, now here we'll take t2 t3 common. So it will be t2 minus t3 and then plus t2 minus t3 plus 2g t2 minus t3 equals to 0. Now here we can take t2 minus t3 common. So we'll take t2 minus t3 common, then we can write this result as a t2 plus t3 t1 plus t2 t3 plus 1 and then plus 2g equals to 0. So from here we'll write the value of g as minus a by 2, and this is t1 t2 plus t2 t3 plus t3 t1 plus 1. If we substitute the value of g in this equation, then we'll get value of f, and value of f in this case it will be minus a by 2 t1 plus t2 plus t3 minus t1 into t2 into t3. So substituting the value of g and f in the first given equation, then from there we can write this c as a square t2 t3 plus t3 t1 plus t1 t2. So now we have the value of g, f and c. Then we can write equation of this circle. So if we write this equation, we can write this equation as x square plus y square plus 2gx will be a t1 t2 plus t2 t3 plus t3 t1 plus 1 into x, and then plus 2fx will be a, and then t1 plus t2 plus t3 minus t1 t2 t3 and then plus c. So plus a square t2 t3 plus t3 t1 plus t1 t2 equals to 0. Now we need to prove that this circle, it passes through focus of parabola. So we know that focus of parabola is a comma 0. So we'll put x as a and y as 0. Then we can write this equation as a square plus 0 minus a will be t1 t2 plus t2 t3 plus t3 t1 plus 1 into a, and then here it should be y, and here will be 0, and then plus a square will be t2 t3 plus t3 t1 plus t1 t2. Now here a and a will become a square, so t1 t2 will cancel, t2 t3 will also cancel, t3 t1 will also cancel, and then a square will cancel with a square, so eventually it will become 0. So that means this circle will pass through focus of this parabola. Now in this video we'll discuss a very important result which is used in solving certain problems, and the result is, suppose we have any general tangent to a parabola, then image of focus about any general tangent will always lie on directrix of parabola. So we'll prove this result for this general parabola which is y square equals 4ax. Now suppose we have this point P whose coordinate is a t1 square twice a t1. Now we'll find equation of tangent at P. So equation of tangent at P is given by ty equals x plus at square. We can write this equation as x minus ty plus at square equals 0. Now we'll find image of focus about this line. So image of focus will be x minus a upon 1, y minus 0 upon minus t, and then minus 2. We'll put the value of x and y, so it will be a plus at square upon 1 plus t square. So 1 plus t square will cancel, we'll get x minus a, y upon minus t, and this is minus 2a. So if we'll solve this x, then we'll get x as minus a, and we'll get y as twice at. So image of focus, suppose it is s dash, it is minus a comma 2at. Now what is the x coordinate? X coordinate is minus a. So that means this s dash, it will lie on directrix of this parabola. So let us take a problem, and the question is, a movable parabola touches the x-axis and y-axis at 1, 0 and 0, 1. Then the locus of the focus of the parabola is. So we need to find locus of focus of this parabola. So first we'll draw this parabola. So now we have a parabola which touches both the axes. So it touches x-axis at 1, 0 and it touches y-axis at the point 0, 1, and we need to find locus of its focus. So suppose focus is alpha, beta. So now we know that the property is reflection of focus about any tangent to a parabola will always lie on directrix of a parabola. So we'll take reflection of S about this tangent, which is y-axis. Then suppose this point is S1. So its coordinate will be minus alpha, beta. And we'll take reflection of S about other tangent, which is x-axis. Then we'll get S2, and which is alpha, minus beta. So now we have 2 points on directrix. We can write equation of directrix from this. So equation of directrix for this parabola will be y minus beta. Now what is the slope? Slope is 2 beta upon minus 2 alpha and then x plus alpha. So 2 and 2 will cancel. So I'll get minus alpha y plus alpha beta, and this is beta x plus alpha beta. So equation of directrix will be beta x plus alpha y is equal to 0. Now it's a locus problem. We need to find relationship between alpha and beta. Now we know that distance of any point from focus is same as distance from directrix. So for this point 0, 1, if we'll write this distance, we'll write this distance as under root of alpha square plus beta minus 1 whole square, and it should be equal to distance of this directrix from 0, 1. So we'll take distance from 0, 1, then we'll get alpha upon under root of alpha square plus beta square. And in the same way, if we'll take distance from this point 1, 0, then in that case we'll get under root of alpha minus 1 whole square plus beta square, and this should be beta upon under root of alpha square plus beta square. Now what we'll do is we'll square and add the two equations. So we'll square and add the two equations. We'll write this as alpha square plus beta minus 1 square plus alpha minus 1 square plus beta square, and here we'll get alpha square plus beta square upon alpha square plus beta square, which is 1. So we can write this equation as 2 alpha square plus 2 beta square minus 2 alpha minus 2 beta, and this is 2 minus 1, and then it will be plus 1. So the locus of focus of this parabola, it will be 2x square plus 2y square minus 2x minus 2y plus 1 equals to 0. Now the second important result that we use in solving problems is foot of perpendicular from focus on any general tangent to a parabola will intersect tangent drawn at vertex of parabola. So we have this focus and then we have drawn a tangent at P. So we'll draw foot of perpendicular from S to this tangent. It will always intersect tangent at vertex. So we'll prove this result. So we'll write the equation of tangent at P. So equation of tangent at P will be Ty equals x plus at square. Now we'll find this point where this tangent, it intersects y-axis. So for this point, maybe say this point is Q. So for point Q, we'll put x as 0. So we'll put x as 0, we'll get y as at. So coordinate of this point Q is 0, 80. We need to show that this Q is foot of perpendicular from focus, or in other words, we have to prove that SQ is perpendicular to PQ. So we'll find slope of PQ. So what is slope of PQ? It is twice AT minus AT upon AT square. So it is 1 upon T, and we'll write slope of SQ, so it will be 0 minus AT upon A, and it is minus T. So product of slope MPQ into MSQ is minus 1. So that simply means this Q is foot of perpendicular from focus. So the result is foot of perpendicular drawn from focus to any tangent to a parabola will intersect tangent drawn at vertex of the parabola. Now let us take a very interesting question, and that is, if y equals x plus 1 is the axis of parabola, y plus x equals 4 is tangent to the same parabola at its vertex, and y equals 2x plus 3 is one of its tangent, then we'll need to find equation of directrix, length of latus rectum, extremities of latus rectum, and the equation of parabola, which is in the form of x minus y plus 1 square equals b upon a, x plus y minus 4 square. Now, how do we solve this question? First, we'll draw this parabola. We have coordinate axis, and then we have this line y equals x plus 1. This is y equals x plus 1, which is axis of parabola, and then we have y plus x equals 4, which is tangent at vertex, and then we have this parabola, and it also says one of the tangent to this parabola is y equals 2x plus 3. So one of the tangent it is y equals 2x plus 3. Now first we'll find vertex of this parabola. So we'll solve these two equations. So we have y equals x plus 1 and y plus x equals 4. So we'll put y as x plus 1. We'll get 2x equals 3. So its x coordinate will be 3 by 2. And if we'll put x as 3 by 2, then we'll get y as 5 by 2. Vertex of this parabola is at 3 by 2, 5 by 2. Now next we'll find focus of this parabola. Now we'll say, suppose the focus is h, k. Now this focus, it lies on axis. So we can write h minus k plus 1 equals to 0. So that's my equation number 1. And then we also know that this foot of perpendicular from focus to any tangent, it will lie on tangent at axis. So we'll first find this point of intersection. So this point of intersection, we'll find it through this tangent at vertex, which is y plus x equals 4, and then this tangent, which is y equals 2x plus 3. So we'll replace y with 4 minus x. So we'll get x as 1 by 3. So say this point is A. So the coordinate of this point A is 1 by 3 and 11 by 3. Now we know that this perpendicular from focus on this line is A. So that means we'll take product of slope and we'll put it equals to minus 1. So then will be k minus 11 by 3 upon h minus 1 by 3 into, what is the slope of this line? Slope of this line is 2, and this is equal to minus 1. So we'll get this as 6k minus 22, and this is minus 3h plus 1. So we'll get this equation as h plus 2k equals 23 by 3. So now we have two equations. So if we'll solve these two equations, we'll get the value of h and k. We'll write this equation as minus h plus k is equal to 1. So we'll add them, we'll get the value of k. We'll get 3k equals 26 by 3. So that is the value of k is 26 by 9. And if we'll put the value of k in this equation, we'll get h as 26 by 9 minus 1, which is 17 by 9. So focus of this parabola is at 17 by 9, comma 26 by 9. So focus is at 17 by 9 and 26 by 9. So we'll write the result here. So we have vertex. Vertex is at 3 by 2, 5 by 2. And focus is at 17 by 9 and 26 by 9. Now we'll need to find equation of directrix. So we'll find base of directrix. So suppose this is our directrix. We'll find base of directrix. Suppose this point is D. So we know that vertex is midpoint of D and S. So if we'll take D as, say, x1, y1, then x1 plus 17 upon 9 by 2 is equal to 3 by 2, and then y1 plus 26 by 9 by 2 is equal to 5 by 2. So we'll get x1 as 10 by 9, and we'll get y1 as 19 by 9. So basically base of directrix is 10 by 9 and 19 by 9. Now we can start solving this question. Now the first thing that we need to find is equation of directrix of parabola. So directrix is a line which is parallel to tangent at vertex. So slope of this line is -1. So that means slope of directrix is also -1. So equation of directrix will be y minus 19 by 9 and minus x minus 10 by 9. So we'll get this equation as x plus y, and this is 29 by 9. So we can write this equation as 9x plus 9y minus 29 equals to 0. And the condition they have given is ax plus by minus 29 equals to 0. Then a plus b is. So a is 9 and b is 9. A plus b is 18. So this option A, it is matched to Q. Now for the second one, we need to find length of latus rectum. So we know that distance between vertex and focus is equals to A. So we'll find this distance. Say we'll find VS, which is A, and it is under root of, and this is 17 by 9 minus 3 by 2 square and plus 26 by 9 minus 5 by 2 square. So we'll get this as 32 minus 27. So that's 7 square, 49 by 18 square. And here will be 52 minus 45. So again there'll be 49 by 18 square. So we can write it as 7 root 2 by 18. Now we need to find length of latus rectum. Length of latus rectum is 4a. So it will be 14 root 2 by 9, which they have given as a root 2 by b. So it is a root 2 by b. So here a is 14 and b is 9. And then what is a plus b? A plus b in this case is 23. So that means b is mapped to R. Now the third thing that we need to find is extremities of latus rectum. So we know that latus rectum is a line which passes through focus and is perpendicular to axis. So what we'll do is we'll say this point is suppose alpha comma beta, and it is at a distance of 2a. And what's 2a? 2a is 7 root 2 by 9 units. So we'll find foot of perpendicular from this point alpha beta on this line, which actually is focus. So we can write this foot of perpendicular as x minus alpha upon 1 y minus beta upon minus 1, and then this distance which is minus. Now we can have 2 points, one up and one down, so we can write it as plus minus 7 root 2 by 9. Now x here is 17 by 9, so we can write 17 by 9 minus alpha equals plus minus 7 root 2 by 9, and this is 26 by 9 minus 26 by 9 plus beta, and this is plus minus 7 root 2 by 9. So here alpha is 17 by 9 plus minus 7 root 2 by 9, and beta is 26 by 9 plus minus 7 root 2 by 9. Now we'll need to find greatest interior function of a1 plus b1 plus a2 plus b2. So we'll need to find greatest interior function value of, this is 17 by 9 plus 7 root 2 by 9, and then 17 by 9 minus 7 root 2 by 9. Here it is 26 by 9 plus 7 root 2 by 9, and then 26 by 9 minus 7 root 2 by 9. So 7 root 2 by 9 will cancel. Here it will also cancel. So we'll get this value as 34 by 9 and plus 52 by 9, and which is 86 by 9. 86 by 9 is 9 point something. So its greatest interior function value is 9. So that means this value, it is mapped to P. Now the last one is, if the equation of parabola is x minus y plus 1 square, and this is b upon a, x plus y minus 4, then we'll need to find the value of b upon a. So we'll compare it with the standard equation, which is capital Y square equals 4a capital X. Now here capital Y is x minus y plus 1, and capital X is x plus y minus 4, and here a is b upon 4a. Now we know that focus of this parabola is at a comma 0. So that means capital X equals a and capital Y equals 0. So we'll take capital X as a. So capital X is x plus y minus 4, and this is equals to b upon 4a. Now we already have focus of this parabola. So focus is at 17 by 9 and 26 by 9. So it will be 76 by 9 plus 26 by 9 minus 4, and this is b upon 4a. So it will be 43 by 9 minus 36, 7 by 9 equals b upon 4a. So we can write b upon a as 28 by 9. Now in this case, what is the value of a plus b? So in this case, value of a plus b will be 28 plus 9, and which is 37. So that means D is mapped to S. So this is how we solve such questions. As the name suggests, focal chord of a parabola is any chord which passes through focus. So if we have any parabola, say y square equals 4ax, and its focus is at a comma 0. So any chord which passes through focus is your focal chord. So the first question could be, focal chord to this parabola y square minus 16x is a tangent to circle which is x minus 6 square plus y square equals 2. Then the possible values of slope of this chord are. Now what we can do is we can take a general equation of tangent to a circle. So we know that a general equation of tangent to this circle will be y equals m, and then in place of x we'll write x minus 6 plus minus. Now what is the radius? Radius here is root 2 into under root of 1 plus m square. Now this tangent to this circle is actually focal chord for this parabola. So that means this tangent, it should pass through focus of this parabola. Now for this parabola, we know that value of a is 4. So its focus is at 4, 0. So this tangent, it should pass through this point. So we'll put the value of x and y. So we'll put y as 0 and x as 4. We'll get minus 2m plus minus under root 2 1 plus m square. We'll take it on the left hand side. We'll write root 2m equals plus minus under root of 1 plus m square. So we'll square it. We'll get 2m square equals 1 plus m square. So that means value of m should be plus or minus 1. So the focal chord to this parabola, which is tangent to this circle, can have slope either plus 1 or minus 1. So that's your option number A. So basically focal chord of a parabola is any chord which passes through focus. Now we'll write the general condition for any focal chord of a parabola. So suppose we say there are 2 points A and B which are endpoints of focal chord, and suppose coordinate of A is at1 square twice at1 and B is at2 square twice at2. So we can write equation of any general chord of a parabola. So equation of any general chord of a parabola is given by t1 plus t2y equals 2x plus 2a t1 t2. Now we know that this chord is a focal chord. So that means this chord, it should pass through focus of this parabola, which is a, 0. So we'll put y as 0 and x as a. So we'll get 2a plus 2a t1 t2. So from here we'll write t1 into t2 equals minus 1. So if a and b are endpoints of a focal chord of a parabola, then in that case t1 into t2 must be equal to minus 1. And this is very important relation which we'll use in solving questions. So if you have any questions on focal chord, then what you can do is we can either write endpoints as a at1 square twice at1 and b at2 square twice at2, and then we can use this relationship which is t1 into t2 equals minus 1. Or another way of writing endpoints is, suppose a is at square 2at, then we know that condition should be t into t dash should be minus 1. So that means t dash should be minus 1 upon t. So we can write other point b as a upon t square minus 2a upon t. So either we can solve question taking t1 t2 with the relationship that t1 into t2 is minus 1, or we can use it in terms of single parameter which is t. So in that case we'll take these points as at square 2at and a upon t square minus 2a upon t. So this is how we'll write endpoints of a focal chord. Now let us take some question. If one end of a focal chord AB of parabola y square equals 8x is at a 1 by 2 comma minus 2, then the equation of the tangent to it at b is. So now we know that this parabola is y square equals 8x. Now what is the value of a for this? Value of a is simply 2. So any general point on this parabola, I can write it as at square and 2at. So it is 2t square and then 2at, which is 4t. Now they have given this a as 1 by 2 into minus 2. So we'll compare this. We'll get the value of t as minus 1 by 2, or should I say it is t1. So it is 2t1 square and then 4t1. Now b is, suppose 2t2 square 4t2. Now we know that if a and b are endpoints of focal chord, then in that case t1 into t2 should be minus 1. So if t1 is minus 1 by 2, then the value of t2 is 2. So in that case, this t2 will simply be 2. So now we can write equation of tangent at B. So equation of tangent at B will be ty, so that is t2y equals x plus a t2 square. So t2 is 2, so it is 2y, and this is x plus, now what's a? A here is again 2, and t square is 4. So we'll get this equation as x minus 2y plus 8 equals to 0, and that's your option number A. Now we'll try to work out formula for length of a focal chord. So length of a focal chord say L, which in this case is AB. So we know that length of any general chord of a parabola is A mod of T2 minus T1 under root of T1 plus T2 whole square and then plus 4. Now we'll try and simplify this relationship using this relation, which is T1 into T2 is minus 1. So we can write it as A mod of T2 minus T1, and this is T1 square plus T2 square plus 2T1 T2, and we can write this 4 as minus 4 into minus 1, and minus 1 is T1 T2, so we can write it as minus 4 T1 T2. So we'll write it as A mod of T2 minus T1, and this again is A square plus B square minus 2AB, so we can write it as T2 minus T1 whole square. So length of a focal chord of a parabola is A into T2 minus T1 whole square. And if we are taking it in terms of parameter T, so we are taking the points as either AT square, 2AT and A upon T square minus 2A upon T. In that case, this length will be equal to A and then T. Now T into T dash is equal to minus 1. So then it will be T plus 1 upon T whole square. So this is how we can write length of any focal chord of a parabola. Consider a parabola y square equals 4ax. The length of focal chord is L and length of perpendicular from vertex to the chord is P. Then which of the following is correct? So we have this parabola which is y square equals 4ax. And then we have this focal chord whose length is L, and suppose these endpoints are AT1 square twice AT1 and AT2 square twice AT2, and we also know that T1 into T2 is minus 1, and length of a focal chord, it is A into T2 minus T1 whole square. So this is all given to us. Now it says length of focal chord is L and length of perpendicular from vertex to the chord is P. So this length, it is P. So we know that equation of any general chord of parabola is T1 plus T2y, and this is 2x plus 2a T1 T2, and we know that T1 T2 in this case is minus 1. So we can write this equation as 2x. Now T1 plus T2 L, so minus T1 plus T2y, and then minus 2a equals to 0. So we'll find P. So what is perpendicular distance from origin? So perpendicular distance from origin will be 2a upon under root of 4 plus T1 plus T2 whole square. So we'll simplify, we can write it as 2a, and this is under root of 4 plus T1 square plus T2 square plus 2 T1 T2, and we know that T1 T2 is minus 1, so we can actually write 4 as 2a, and this is under root of minus 4 T1 T2 plus T1 square plus T2 square plus 2 T1 T2. So this is 2a, and we can write it as t1 square plus t2 square minus 2t1 t2. So it is t1 square plus t2 square minus 2t1 t2. So we can simply write this p as 2a upon mod of t2 minus t1. Now we can eliminate t2 minus t1. So we'll just put this value. So we'll put the value of t2 minus t1 here. So we'll get L equals a into, and this is 4a square upon p square. So from here we'll get this result as this L into p square is 4a cube, which is constant. So answer to this question is option number B. Now the third important result in case of focal chord is, suppose L1 and L2 are focal distance of points A and B, then we need to find harmonic mean of these focal distances. So we need to find harmonic mean of L1 and L2. We know that harmonic mean will be 2L1 L2 upon L1 plus L2. Now we know that focal distance L1, it is a plus at square. So we can write L1 as a plus at1 square, and in the same way we can write L2 as a plus a t2 square. So if we'll find harmonic mean of these focal intercepts, then it'll be 2. We'll take a common. It is 1 plus t1 square a, and then 1 plus t2 square, and then if we'll add them, I'll take a common, we'll get 2 plus t1 square plus t2 square. Now I'll multiply these two factors. So I'll write harmonic mean as this a and a will cancel. So it is 2a, and this is 1 plus t1 square plus t2 square plus t1 square t2 square upon 2 plus t1 square plus t2 square. Now we know that t1 into t2 is minus 1. So t1 t2 square will be plus 1. So we'll get this harmonic mean as 2a, and this is 2 plus t1 square plus t2 square, and this is 2 plus t1 square plus t2 square. So we'll cancel. So basically harmonic mean of these two line segments or these two segments of vocal cord, so it is 2L1 L2 upon L1 plus L2 is equal to 2a, which is semi-lattice vector. So this is our third important result. Now here the question is, if L1 and L2 are lengths of segments of any focal chord of parabola y square equals x, then 1 upon L1 plus 1 upon L2 is equal to what? So we know that 2L1 L2 upon L1 plus L2 is equal to 2a. So we'll cancel this 2. So we can write L1 plus L2 upon L1 L2 is equal to 1 upon a. Now in this case, what is a? Now a for this parabola is simply 1 by 4. So 1 upon a is simply 4. So from here we'll write 1 upon L1 plus 1 upon L2, and this is simply 4. So answer to this question is C. Now the important result is tangents drawn at end points of focal chord, they intersect at directrix. So this is a focal chord, and tangents drawn at extremities of a focal chord, they intersect at directrix. So we have this focal chord, and suppose this point is a t1 square twice a t1, and this is a t2 square twice a t2, and we know that since it is a focal chord, then t1 into t2 is minus 1. Now if we draw tangents at these 2 points, say A and B, then we know that point of intersection of tangents drawn at A and B, it will be a t1 t2 and then a t1 plus t2. Now since A and B, they are endpoints of focal chord, so that means t1 into t2 is minus 1. So if we'll put t1 t2 as minus 1, we'll get this result as minus a, and this is a, and it is t1 plus t2. So its x coordinate is minus a, which is independent of T1 and T2. So it simply means if tangents are drawn at end points of a focal chord, then they'll always intersect at directrix. And another result in this is these two tangents, they'll always be perpendicular. How do we do that? So we know that slope of any tangent drawn at point A, it is 1 upon T1. And slope of tangent drawn at B is 1 upon T2. So we'll find M1 into M2. Then M1 into M2 is 1 upon T1 into T2, and which is -1. That simply means if we draw tangents from endpoints of a focal chord of a parabola, then they'll intersect at directrix and they'll always be perpendicular. So this is very important result which we'll use again and again. Now this result is equally important other way around. Suppose we have any point which is P, and from this point pair of tangents are drawn to this parabola, then we can prove that this chord of a parabola, it will be a focal chord. So say from this point P, we draw two tangents to this parabola, which intersect this parabola at T1 and T2. So we have this point P, which lies on -a, comma, some value of y, say y1, and it touches this parabola at 2 points, maybe m, which is at1 square twice at1, and n, which is at2 square twice at2. Now we know that for these 2 points, their point of intersection is at1 t2 and then a t1 plus t2. So we'll compare, we'll get t1 into t2 equals -1. So it simply means if pair of tangents are drawn from any point on directrix, then the chord of contact will always be a focal chord. And then again, in the same way, we can prove that we'll find m1 1 upon t1, m2 is 1 upon t2. So m1 into m2 will be -1. So I'll revise again. So the fundamental is if tangents are drawn at the end points of focal chord, then these tangents, they'll be perpendicular and they'll intersect at directrix of a parabola. Now this result, it is also related to something called as director circle. So you must have studied in circles that a director circle is locus of a point from which a pair of perpendicular tangents can be drawn. So we need to find locus of any point P from which pair of perpendicular tangents can be drawn to this parabola, which is y square equals 4ax. Now we know that equation of tangent to parabola is y equals mx plus a by m. Now these tangents, they pass through alpha comma beta, so we can write this as alpha m square minus beta m and then plus a equals to 0. So if we write product of slope, we write m1 into m2 as a upon alpha, and since we are talking about perpendicular tangents, so that means m1 into m2 is -1. So we'll get this locus as alpha equals -a. So it is x equal to -a. So in case of parabola, the equation of director circle is x equal to -a, which actually is directrix of parabola. So in case of parabola, this term director circle is actually a misnomer. It is not a circle. It is a line which is directrix of parabola. So all these three results, they mean the same thing. So any tangents drawn from a point from directrix, they'll be perpendicular and they'll form focal chord, or tangents drawn at endpoints of focal chord, they'll be perpendicular and they'll always intersect at directrix of parabola. Now here the question is, the equation of tangent to a parabola y square equals 8x is y equals x plus 2. The point on this line from which other tangent to parabola is perpendicular to the given tangent is. So we are given this parabola which is y square equals to 8x, and then we are also given this tangent which is y equals x plus 2. Now the point on this line from which other tangent to parabola is perpendicular to the given tangent. We know that point of intersection of perpendicular tangent is directrix. So this point, it should lie on directrix of this parabola. And we know that for this parabola, value of a is 2. So directrix is x equal to minus a, minus 2. So this point is x is minus 2. And when x is minus 2, y is 0. So this point is minus 2, 0. So answer to this question is B. Now the question is, if two tangents drawn from a point to the parabola y square equals 4x are at right angles, then locus of P is. So we clearly know this is the definition of director circle, and director circle in case of parabola is nothing but directrix. So locus of P is simply directrix of this parabola, and directrix of this parabola is x equal to minus a, which is x equals minus 1, and that's your option number B. Now the question is, number of points on the curve y equals mod of 1 minus e to the power x minus 2, from which two perpendicular tangents can be drawn to parabola x square equals minus 4y. Now this is parabola of the fourth form. So we clearly know that if from a point perpendicular tangents can be drawn, then that point, it must lie on directrix of parabola. Now for this fourth form, equation of directrix is y equals a, and a in this case is 1. So it'll simply be y equals 1. Now we need to find number of points on this curve which lies on this directrix. So what I'll do is I'll put y as 1. So we'll put y as 1, we'll get mod of 1 minus e to the power x minus 2, and it is 1. So I'll write mod of 1 minus e to the power x minus 2, it is plus or minus 1. So 1 minus e to the power x, and it is either 1 or 1 minus e to the power x, it is 3. So then we can write 1 minus e to the power x is either plus minus 1 or 1 minus e to the power x is plus or minus 3. So we can write e to the power x as, so we'll put plus 1, then e to the power x will be 0. If we'll take minus 1, then e to the power x will be 2. If we'll take plus 3, then e to the power x will be minus 2. And if we'll take minus 3, then e to the power x will be 4. Now e to the power x, it cannot be 0 because it is 0 at minus infinite, and it cannot be negative. So the two values are at x equals log 2 and x equals 2 log 2. So number of points on this curve is simply 2, and that's your option number A. Another way of solving the same question could be using graphs. So we'll start with our basic graph, which is y equals e to the power x. So that's your y equals e to the power x. Now we'll draw the graph of minus e to the power x. So that is the graph of y equals minus e to the power x. Now we'll draw the graph of y minus 1 equals minus e to the power x. So I'll shift this entire graph plus 1 units along y-axis. So now it will be this graph. Now we'll take mod sign. So we'll find mod of 1 minus e to the power x. So we'll take mod, then it is reflection of down on up, and then erase the point from third and fourth quadrant. So we'll get this graph as now we'll draw the graph of y plus 2 equals 1 minus e to the power x. So we'll shift this graph minus 2 unit down. So we'll get this graph as and then we'll take the mod of this function, which is y mod of 1 minus e to the power x minus 2, and then mod of this function. So we'll take the reflection of this graph. We can draw this graph as now we need to find number of point of intersection between this graph, between this graph and y equals to 1 line. So we'll draw y equals to 1 line. These two graphs, they intersect at these 2 points. So number of solutions in this case will simply be 2. So answer to this question is 2, which is option number A. Now here the question is, find the angle between the tangents drawn to parabola x minus 3 square plus y plus 4 square equals to 3x minus 4y minus 6 whole square upon 25. So this equation is represented in the form of PS equals PM. Focus of this parabola is at 3, minus 4. Now we need to find angle between the tangents drawn to the parabola at the extremities of this chord. So we'll put the value of focus in this equation. We'll get this equation as 6 plus 12 minus 18, which is 18 minus 18 equals to 0. So that means focus lies on this chord. So this chord is actually a focal chord. And we know this result, that angle drawn between the tangents at the extremities of focal chord is 90 degrees. So that means answer to this question is pi by 2, and that's your option number D. Now here the question is, if A and C are lengths of segment of any focal chord of parabola, y square equals 2bx, then we need to find nature of roots of this equation, which is ax square plus bx plus c. Now for this parabola, we know that A is b by 2, and we know that for any focal chord, harmonic mean of segments of focal chord, they're equal to semi-later set, which in this case is b. So from here we can say b is simply harmonic mean of A and C. Now we also know that harmonic mean is always less than equal to its geometric mean. So b is less than equal to under root of AC. So we can write b square minus AC is always less than or equal to 0. Now we look at this quadratic equation. Now for this quadratic equation, what is the value of d? D is b square minus 4AC. So we can write it as b square minus AC and then minus 3AC. Now b square minus AC, it is less than or equal to 0. Now A and C, they are both lengths of segments, so they are both positive. So this value is also negative. So clearly we can say this D is less than 0. And when D is less than 0, that simply means roots of this quadratic equation, they are imaginary. So it is option number C. Now the question is, if P1, P2 and Q1, Q2, there are two focal chords of a parabola which are at right angles, then which of the following is correct? So we have this parabola, which is, suppose y square equals 4ax. And then we have this focal chord. Say P1, P2. Now focus is at a, 0. And suppose this chord, it makes an angle alpha with x-axis. Now this point is at1 square twice at1, and this point is at2 square twice at2, and we know that t1 into t2 is minus 1. Now we know that slope of any chord of parabola is 2 t1 plus t2, and this slope, it is equal to tan alpha. So we can write t1 plus t2, and this is 2 cot alpha, and we also know that t1 into t2 is minus 1. So from here, if we'll write t2 minus t1 whole square, so t2 minus t1 whole square will be t1 plus t2 whole square, and then minus 4 t1 t2. So we can write this as 4 cot square alpha and then plus 4. So we can write t2 minus t1 whole square, and this is 4, and 1 plus cot square theta is cosec square theta. So it will be cosec square alpha. So we know that length of any focal chord is a into t2 minus t1 whole square. So length of this chord p1, p2, it is 4a cosec square alpha. So now we have this result that if the inclination of a focal chord is alpha, then its length is 4a cosec square alpha. Now we'll consider this other chord which is Q1, Q2. So suppose this is Q1, Q2. And suppose it is inclined at an angle beta. So we know that L2, so which is Q1, Q2, it should be 4a cosec square beta. So we know that alpha plus pi by 2 is equal to beta. So we can write beta as pi by 2 plus alpha. So we can write L2 as 4a, and this is cosec square beta. So we can write it as cosec square pi by 2 plus alpha, and which is secant square alpha. So that's your length L2 of focal chord. Now we need to find area of this quadrilateral, which is P1 Q1, P2 Q2, and we know that angle between diagonals is 90 degrees. Now since we know that this angle is 90 degrees, so area of this quadrilateral, which is P1 Q1, P2 Q2, it will simply be 1 by 2 D1 D2, and D1 D2 in this case is L1 and L2. So it will be half L1 L2. So we'll put a value of L1 L2, we'll get 16. So it will be 8a square, and we can write it as sine square alpha and cos square alpha. Now we'll multiply it with 4 and divide it with 4. So we can write it as 32a square upon, and this is sine 2 alpha whole square. Now this area, it will be minimum when the expression in the denominator is maximum, and we know that maximum value of sine square theta is 1. So in this case, basically sine square 2 alpha, it should be 1. So that means value of alpha should be pi by 4. And if we'll put alpha as pi by 4, we can get this minimum area is 32 into a square. Now it says area of square on latus rectum of parabola. So we know that length of latus rectum is 4a. So what is the area of square? So area of square simply will be 16a square. So answer to this question is area of this quadrilateral is minimum when focal chords are inclined at an angle pi by 4 with the axis of parabola, and minimum area is twice. So it is 16a square and it is 32a square. It is twice the area of the square on the latus rectum of the parabola. So answer is option A and B. Now here the question is, let PQ be a focal chord of parabola y square equals 4ax. The tangents to parabola at P and Q meet at a point lying on the line y equals 2x plus a. And now it is given that PQ is a focal chord. So we'll first draw this parabola. So that's y square equals 4ax, and then we have this chord PQ and passes through focus, which is a comma 0. So let P is a t1 square twice a t1, and Q is a t2 square twice a t2. Now it says the tangent to parabola at P and Q meet at a point lying on this line. Now we already know that tangents drawn at endpoints of focal chord intersect at directrix. So that means for this point of intersection, its x coordinate will be minus a. So we'll put minus a here. We'll get the value of y as minus a. So these two tangents, they'll intersect at minus a comma minus a. So this point of intersection is minus a comma minus a. So now we can say point of intersection is a t1 t2, and this is a t1 plus t2. From here we can write this is minus a and this is also minus a. So that means t1 into t2 is minus 1 and t1 plus t2 is also minus 1. Now the first question is find the length of this chord PQ. So we know that length of a focal chord is given by a t2 minus t1 whole square. So it is a, and we can write this is t1 plus t2 whole square minus 4 t1 t2. So it will be a. Now what is t1 plus t2 whole square? It is 1. and then plus 4. So length of this focal chord is equal to 5a, and that's your option number B. Now next question is, if the chord PQ subtends an angle theta at the vertex, so we are talking about this angle, then we need to find the value of tan theta. We can find the slope of OP. So slope of OP is 2 upon T1, and slope of OQ is 2 upon T2. That means this tan theta, it will be this mod value. Now 2 upon T1 minus 2 upon T2 upon 1 plus 4 upon T1 T2. So we can write this as 2 times T2 minus T1, and this is T1 T2 and plus 4. Now we know that T2 minus T1 is under root 5. So we can write this as 2 root 5 upon T1 T2, which is minus 1. So 2 root 5 upon 3. Now the problem is, we use this formula to find angle between two lines. We always find out the acute angle between the two lines. But here in this case, here we are not talking about two lines. Here we are talking about these line segments OP and OQ. So we need not find this acute angle. We have to find this exact angle theta between POQ. Now we know that latus rectum makes an angle around 120 degrees. So any other focal chord, it will make an angle which is again an obtuse angle. So this angle will be an obtuse angle, and if the angle is obtuse, then in that case value of tan theta, it should be negative. So it should be minus 2 root 5 by 3, and that's your option number D. In one of the previous videos, we have discussed how to write equation of tangent, and we have also discussed how to write equation of chord of contact. So the condition was, if we have any parabola, say y square equals 4ax, and we have any point P, which is say x1, y1, which lies outside of parabola, then we can draw a pair of tangents from this point, and if we'll touch these two contact points, then we'll get chord of contact. Now we know that in this case, the equation s equals to 0, it is y square minus 4ax equals 0. S1 is, we'll just put the value of x1, y1 in the equation. So we'll get y1 square minus 4ax1, and it will be greater than 0 because the point lies outside of parabola. And we also know that equation of chord of contact is given by t equals 0, which in this case is y1 minus 4a x plus x1 upon 2 equals 0, which is y1 minus 2ax minus 2ax1 equals 0. So we have already discussed this in previous video. Now in this video, we wish to find length of this chord of contact and also area of triangle formed by these tangents and this chord of contact. So for that, what we'll do is, we'll say these contact points are, suppose A and B. Say A is AT1 square twice AT1, and say B is AT2 square twice AT2. And this point P, it is x1, y1, and we also know that this point of intersection of tangents is AT1, T2, and this is A T1 plus T2. So we can write T1 into T2 as x1 upon A, and we can write T1 plus T2 as y1 upon A. Now, first thing that we need to find out is length of this chord of contact. Length of this chord of contact, which is AB, it is given by A mod of T2 minus T1 under root of T1 plus T2 whole square and then plus 4. Now we already have T1 plus T2. We also have T1 into T2. So here we'll find T1 minus T2 mod. And it is given by under root of T1 plus T2 whole square minus 4 T1 T2. So it will be under root of, now what is T1 plus T2? It is y1 square upon a square minus 4, and T1 T2 is x1 upon a. So here I can write it as under root of y1 square minus 4ax1 upon a square. Now y1 square minus 4ax1 is nothing but s1. So we can write mod of T1 minus T2 as under root of s1 divided by a. Now we can write length of this chord. So length of this chord of contact will be a, and then it will be under root of s1 upon a, and then under root of T1 plus T2 square. T1 plus T2 square will be y1 square upon a square, and then plus 4. So this length will be a, and a will cancel. So it will be under root of s1 into under root of y1 square plus 4a square upon a, and that is the formula for length of this chord of contact. So now we can say this length L is under root s1, and this is under root of y1 square plus 4a square upon a. Now we'll find area bounded by these tangents and this chord of contact. So what we'll do is we'll find perpendicular distance of chord of contact from this point. So we'll find this distance, say d. So we know that equation of chord of contact is given by y1 minus 2ax minus 2a, x1 equals to 0. Now we'll find this perpendicular distance from this point. So this d, it will be, so we'll put the value of x and y. So we'll get y1 square minus 2ax1 minus 2ax1 upon under root of y1 square plus 4a square. So we can write this as y1 square minus 4ax1, which is nothing but it is s1. So it is s1 upon under root of y1 square plus 4a square. Now we can write this area as 1 by 2, and then base, which is length of this chord, and then into this perpendicular distance, which is d. So it will be half, and then L is under root of s1 under root of y1 square plus 4a square upon a into s1 upon under root of y1 square plus 4a square. So it'll cancel. So we'll write this as 1 upon 2a s1 to the power 3 by 2. So area of triangle formed by pair of tangents and chord of contact is 1 upon 2a s1 to the power 3 by 2. Now the question is, the tangent is drawn at any point on parabola y square equals 8x, and on it is taken a point Q from which a pair of tangents QA and QB are drawn to this circle x square plus y square equals 8. So we'll draw this figure. So we have this circle, and then we have this parabola, that is y square equals 8x, and equation of this circle is x square plus y square equals to 8. Now it says a tangent is drawn at any point on this parabola. So let us take any point on this parabola. So suppose this is point P, which is AT square twice AT, and then from a point Q on this tangent, so we'll have to consider a point Q on this tangent, say Q, which is say alpha beta. Now from this point, a pair of tangents is drawn to this circle. Now using this information, we need to answer the following question. Now the first question is locus of point of concurrency of chord of contact AB of the circle x square plus y square equals to 8. Now we know that equation of chord of contact drawn from any point Q on this circle will be given by t equals 0. So we can write this equation as alpha x plus beta y minus 8 equals to 0. Now we can also write equation of tangent to this parabola at this point P. So equation of tangent to parabola at point P, it is given by ty equals x plus a t square. Now we know that this point Q, it lies on this tangent. So we can write this equation as alpha minus beta t plus at square, it should be 0. Now from these two given conditions, we can find this fixed point, which is point of concurrency of all the chords. So we'll take this x here, this is x, and coefficient of alpha here is 1, and this is equals to y upon minus t, and it is minus 8 upon at square, and a in this case is 2, so it will be 2t square. So we can write this x as minus 4 upon t square, and we can write this y as 4 upon t. Now we'll eliminate this value of t, so we can write this as x equals minus 4, and it will be 16, and this is y square, so its equation will be y square plus 4x equals to 0, and that's your option number C. Now the next question is the point from which perpendicular tangents can be drawn to both the given circle and the parabola. Now we know that perpendicular tangents can be drawn from director circle. So for this circle, if we'll write equation of director circle, it'll be x square plus y square equals 2a square. So there'll be x square plus y square equals 16, and equation of director circle in case of parabola is nothing but directrix. So equation of directrix for this parabola will be x equals minus a. So it will be x equals minus 2. Now the point from which perpendicular tangents can be drawn both to the given circle and parabola will be the point of intersection of director circle with directrix. So what I'll do is I'll put the value of x as minus 2. We'll get this as 4 plus y square equals 16. Y equals plus minus under root 12. So there'll be plus minus 2 root 3. So the points from which perpendicular tangents can be drawn to both the given circle and parabola will be minus 2 comma plus minus 2 root 3, and that's your option number D. Now the third question is locus of circumcircle of triangle AQB. So we have this point A, and then this point of contact is B. We need to find equation of circumcircle of this triangle AQB. So we know that circumcircle of triangle formed by pair of tangents and chord of contact will pass through center of this given circle. So that means this circle will pass through center of x square plus y square equals to 8, which is origin. So it is 0, 0. And this point is alpha beta. Now this angle A and angle B, it is 90 degrees. So it simply means this OQ, it is diameter of circumcircle. So if OQ is diameter of circumcircle, then we need to find locus of circumcenter. So let circumcenter be h comma k. So using midpoint formula, we can write alpha upon 2 equals h, beta upon 2 equals k. So from here we'll write alpha equals 2h and beta equals 2k. Now we already know that this alpha beta, they lie on this tangent, so which is alpha minus beta t plus a t square equals 0. So we'll put the value of alpha and beta. Alpha is 2h and beta is 2k. So we can write this as 2h minus 2k t and then plus at square equals to 0. Now in the question, it is given that t is equal to 2 and a is also 2. So we can write this equation as 2h minus 4k, and this is plus 8 equals to 0. So this equation will be h minus 2k plus 4 equals to 0, which is x minus 2y, and then plus 4 equals to 0. So locus of circumcenter of this triangle AQB will be x minus 2y plus 4 equals to 0, and that's your option number C. Now in this video we'll discuss equation of a chord with given midpoint and equation of diameter of a parabola. So suppose we have any parabola which is s equals to 0, and say in this case it is y square minus 4ax equals 0. Now suppose we have any chord of this parabola whose midpoint is, say, x1, y1. Now with the given equation and with given midpoint of chord, we can write equation of this chord. So equation of chord with a given midpoint, say x1, y1, is given by t equals s1. So in previous videos, we have already discussed how to find t equals to 0 and how to write s1. So from this equation, if we'll write t, we'll write this t as y1 minus 2ax minus 2ax1. And what is s1? S1 is y1 square minus 4ax1. So equation of chord whose midpoint is x1, y1 is given by this equation, which is t equals s1. So say for example, suppose we have to write equation of chord of parabola y square minus 8x equals to 0, whose midpoint is, say, 2, 3. So we know that this equation is given by t equals s1. So we can write this equation as 3y minus 8 x plus 2 upon 2, and this is y square, which is 9 minus 16. So it will be 3y minus 4x minus 8, and this is minus 7. So this equation will be 4x minus 3y and then plus 1 equals to 0. So the chord of parabola y square equals 8x, whose midpoint is 2, 3, is given by 4x minus 3y plus 1 equals 0. Now we'll discuss equation of diameter of a parabola. Suppose we have a parabola which is, say, y square equals 4ax. So let us draw this parabola. Now if we take a system of parallel chords, and for each chord, if we'll find the midpoint, then locus of midpoint of these parallel chords is called as diameter of a parabola. So basically diameter of a parabola is locus of midpoint of a system of parallel chords. So suppose we have a system of parallel chords which is given by y equals mx plus c. Now here m is fixed, that is all these lines, they have same slope, and then this c is variable. And we have to find locus of midpoint of these chords. So since it is a locus problem, first step is we'll identify this point. We'll say, suppose this point is m and it is given by alpha, beta. Now with given midpoint, we know that we can write equation of a chord as t equals s1. So we can write this equation as beta y minus 4a x plus alpha upon 2, and this is beta square minus 4a alpha. So we can write this equation as beta y minus 2ax minus 2a alpha, and this is beta square minus 4a alpha. Now, we know that any chord has a slope which is m. So we know that slope of this chord. So what is the slope of this line? Slope of this line is minus coefficient of x upon coefficient of y. So it will be minus of minus 2a upon beta. So from here we can write beta as 2a by m. Now we'll replace alpha with x and beta with y. So we'll get this equation as y equals 2a by m. So equation of a diameter of a parabola y square equals 4ax will be y equals 2a by m. So it will be a line which is parallel to axis of parabola and at a distance of 2a by m units from origin. Now the question is, we are given a parabola y square equals 8x. So we have this parabola which is y square equals 8x. Now for this parabola, value of a is 2, and then we have directrix at x equals minus 2 and focus is at 2, 0. Now we have a point on this directrix and which is minus 2, 4, and it is this point P. Now from this P, we'll draw two tangents. So it will be tangent at some place and then we can join this. Suppose this is Q and this is Q dash. That is simple property that from any point on directrix, perpendicular tangents can be drawn to parabola. So this triangle PQQ dash will be a right angle triangle. So this option B, it is correct. And also we have the second property that portion of tangent intercepted between the point of tangency and directrix, it always makes an angle 90 degrees at the focus. So that means this option A is also correct. And we also know that these perpendicular tangents, they always pass through focus of parabola. That is, this QQ dash will be a focal chord. So this option D is also correct, that F lies on line joining Q and Q dash. Now P is minus 2, 4 and F is 2, 0. So this PF will be this under root. Now this is 4 square plus 4 square, which is 32, which is simply 4 root 2. That means this option C is incorrect. So the correct options are A, C and D.